Hey team, it is absolutely wonderful to see you. It's very likely that you're actually watching the recording. If so, fast forward several minutes because I'm just about to send a bunch of invitations around. I'm really excited to get people's questions, and even if we don't, we'll start to learn some Rust. And yeah, hey, my name is Tim Clicks. I'm on the planet to build a better planet. I'm here to help you learn Rust and make use of it to build amazing software. Okay, so just bear with me while I go send some invitations for people to join. Otherwise, I'll just be talking to myself, which I suppose is also something that's fun to do. But let's say something that is worthwhile to avoid if we can. Okay, so I just send one out to my Discord server. Boom. Send an invitation out to Blue Sky. Mastodon, Twitter. Oh, I could even send it out to LinkedIn. I haven't done it today because the LinkedIn audience is a little bit more, I'd say, expecting a little bit more than just some sort of impromptu rambling, which is what I intend to do now. You are very welcome to ask any questions. In fact, there've already been a few questions. So hello, sup, and howdy to you, and howdy from Dallas. So Bitspiel, I presume that is from Germany, and we've got some from David here from Dallas, which means we've already got a very international audience. And I am just going to not even try to guess where Coda like Miley is. But rock on, Miley. If she was coding, she would be coding in Rust. I guarantee it. Right. Okay. So last message getting sent out on the internet. Although ironically, in some sense, you could say that the in some sense, like these social networks aren't really a very good version of the internet. I wonder, like, even Discord feels very private, whereas like, you know, revealing age, but back in the 90s the internet was all like bulletin boards, like forums and stuff, which you actually could visit the public. Oh, okay, so we're all American. So wait, so Bitch Peel is actually from just out of Austin, quite a long way still from Dallas, where David is from, but potentially you could send up some, like, you could beam to each other through the ionosphere and like HF radio, probably from Austin to Dallas. PH, so I'm going to say that's Philadelphia. So if you're over on the East Coast, it's probably already very late. So I appreciate very much that you're with me. And Quebec. Sadly, my French is awful, and I'm not going to embarrass myself about saying bonjour. And even that's probably not very Quebecois. Well, I probably got that wrong too. Anyway, Philippines. Okay, so the Philippines rather than Philadelphia. So that's even more fun. So you're actually much more in my time zone. I'm calling from New Zealand. It's lovely to talk to everyone across the Pacific. Hey, Rob, you should be in bed. I know where you live. You're based in the United Kingdom. And unless you have suddenly gone rogue and you have moved, and the reason, sorry, I'm just pausing because I want to bring up an episode that I did on my podcast, which I should actually share online. I'm not doing this to pump my podcast. I just thought, because Rob has dropped in very late at night, we should kind of honor that by saying, by the way, Rob's a very nice person, and one of the things that he did was start my podcast. And now I've had several episodes, and the problem with that is I can't even find my own archive page with Rob's one. So he's sort of fallen off, and I can't find the rest of them. That's highly embarrassing. Let's see if I can click into this one from Rahul Kumar, and oh man, this is more embarrassing than what I thought. There we go. So there's Rob. I'm sure we could find him. There we go. There's Rob's. There he is. Look at that. He's a dashing fellow. So thanks, Rob, for joining us, even though it is very late. 23. Oh, so you're saying good morning to me because it's my morning. Aha. I'm going to post a comment has just come out from me, and I'll just get another one. We will start very soon. So it's really awesome to see several comments and questions coming through. You're very, very welcome to you are very, very welcome to ask questions. We're going to be trying covering as much Rust as I can until my voice essentially gives out. We'll spend about an hour or so together. If you feel like dropping out, that's absolutely fine. You can also just leave a question or comment in the chat. And I'll try to get to it even if you've left, and hopefully you can view the recording. If you are watching the recording and you think, gosh, I really wish that I'd asked Tim this, or could he finish the explanation of that? Because I'm bound to let things out. What I would like to share with you is my Discord server. Again, not to pump the like a particular not because I'm trying to do the classic. This is impossible to search for. Clicks Lounge is actually just easier to find, actually. So if you just, oh gosh, what did I do? There we go. I lost the window. If you hunt for Clicks Lounge, you'll find me. You can come and join us. There's about 1,000 of us. Ask any questions in there, and we will try to kind of facilitate that discussion. Okay, so hopefully by now we have a couple of questions queued up, and let's go and to answer them. So we're here to talk about this programming language, Rust. Rust is quite cool because I find it very energy efficient, and it is also very robust. So if you're still learning the language, one of the things that really distinguishes it is its focus on what I would call, essentially, it gives you kind of structure, which doesn't exist but in other languages. Let's talk about JavaScript, for example, just for fun, because everyone loves to hate JavaScript. And the one thing that JavaScript and Python is the same, PHP is the same, Perl is the same, if anyone still uses Perl. Most languages are very similar. In fact, Java is still the same with one particular quality. If I have a string, let's say we've got some text, and we're going to give a type hint, say it's a string, but it's not necessary, and I will create a string from a string literal. And there's a question mark around why you would need a different type for a string from a string literal, but let's ignore that for now. One of the things that Rust really shines out for me is distinguishing the notion of an empty string from something that is uninitialized. And that may seem like an arbitrary distinction, but you'll notice that we have as a type hint this string with a capital S. We don't have bar null, which is what you'll see in most other languages, that you have this kind of hidden possibility of null being anywhere. This is the real benefit to Rust, is that you know that when you ask for some text, that it will be there if you have a string type. Now, it may still be empty, but even if you have the empty string, what you get is that that has sort of semantic meaning. Unlike Go, which will, let's say we've got a number, and we'll say it's n. In Go, the 0 value for a type is the default constructor, essentially. It's kind of what happens if you just ask for a value, even if you had something that was uninitialized. So here I'm attempting to have a value n that is 4 bytes wide or 32 bits, and I want to print that out. At the moment, there is no value at all. It hasn't been initialized in memory. So it's actually undefined what n is. This will refuse to, this will not compile. Rust is very sure that that n hasn't been given any value at all. Therefore, it doesn't make any sense to print it out because there's nothing to print out. Yes, in principle, it could read the bytes that are currently at the memory location of the place where the compiler has reserved 4 bytes, but that would be completely arbitrary. And so, whereas Go will say, no, it's a 0. That has a real problem, and that it's impossible later on to distinguish an uninitialized value from a 0 value. And so that is just the starting place for our discussion, that Rust places a very significant level of robustness on all of our programs. We need, and with that, I'm going to start asking some questions. Okay, so, gosh. First comment was from Bunbury. Really enjoyed reading your book, Rust in Action, from Manning. Oh, that's awesome. In fact, I should just point out, so I seem to be the only person that knows that there's a cheat code, like a short URL. But this is the book that Bunbury's mentioning. I didn't manage to seed any so it's actually somewhat old now. It came out in 21. Second edition is in the pipeline. Hopefully we will have some public announcement even this week. I've been promising this for multiple months now. And so really looking forward to introduce even more programmers to the language. I spent many years writing that book, nearly 5, and it's just been an absolute privilege to introduce what has turned out to be hundreds of thousands of people to the language. Sadly, for me, from my bank account's perspective, only a tiny number of them have actually paid for the book, but that's okay. If you still are interested in buying it, by the way, I've got, if you go to the web, oh gosh, clearly I have set this up wrong. I didn't even realize it doesn't have the naked URL supported. So this is rustinaction.com. And I'll just post this. Here's the URL, and there we go. Beep beep. There's there it is. If you go down and down, there's a bunch of comments, and the thing that I'm interested. Oh, there's an old picture of me. Is this here? Oh gosh, a 42% discount is available for anyone using the code SL McNamara. Okay, so let's talk more about the language. Any plans for a follow-up book? Oh gosh. Yes, so there's actually there's actually multiple books, actually drafts that I've got. The thing that I really need to do now is update Rust in Action, and there are a couple of other more specific things that I want to build. I have so we'll just leave it there. Okay. Along these lines, how RAM bladders used to prevent earthquakes. Look, my Monty Python is actually really, really poor. So I'm just going to say that joke like flew past me. I only know like I know things that are introduced very commonly in like in the Python community because I was from Python. So I've seen jokes, but actually I've never watched The Life of Brian, and I've never watched other Monty Python actual The Holy Grail. I've only seen fragments of. So I'm embarrassed as a resident, or actually citizen, of a British colony, not knowing enough British humor. But actually, quick question. When would you use string from versus toString? Oh gosh, so this is interesting. So from a point of view of like this, there is like a so the line 4 here is incidental, essentially. What we're focused on is line 2. The structure that I'm using here is what I used several minutes ago. The question is, why would you do this instead of, for example, the toString method implemented on string slices? And in fact, that's not the only one that you can do. So let's embarrass ourselves even further by, in fact, I'll just answer the question. I like to use string from for purely aesthetic reasons. I prefer starting with the type that I will become and saying that, like, essentially I am going from something else into this. And so for me, I like to structure my code so that it's sort of subject, verb, object from like an English grammatical point of view. However, I've probably just mixed up subject and object. Then I'm just, if I think about it from like a word, from a grammatical point of view, I personally like string from, so I tend to find myself using it. If you are deciding which to use, you have like entered a topic that I find that I'm really passionate about, which is that Rust has too many points that introduce uncertainty or anxiety for beginners. Tip 1 is it's okay to be wrong. Your judgment will come. So I like to introduce what I think the fundamental tip of learning Rust is that it's okay to write unidiomatic Rust code. When you're learning a language or a new culture, of which Rust is a cultural artifact, essentially, you don't know the cultural norms yet. You don't know the etiquette. Just as if someone was to enter your home and you were to you invite them over for dinner, it's likely that they would do things differently than you. Or it's actually more obvious when you go to someone else's house and you feel uneasy because you don't quite know what's appropriate and what's not. That's the same sort of thing that's happening here. You want to fit in because you want to do the thing that is appropriate. And so you spend a lot of time, probably more time than is necessary, thinking about things like, which method should I call? What would a Rust programmer do? There's 2 reasons why I think that this is something that you should give yourself permission to ignore for now. Although one is, actually there's 3. One is, it's impossible to completely ignore. The fact that you're attempting to think in the language means that you're acting at a higher level than other people who would just blindly walk into a new environment without caring. So you could imagine welcoming someone into your home, and you might have a practice where, I don't know, setting the table works differently, or you always have soup before the main meal, or something that most people around you don't do, or for some reason, you care a lot about, I don't know, maybe someone in your family really cares about which cups are being used in which place. As a teenager, I spent time overseas as an exchange student and made the mistake of placing my cup on the wrong side of the plate, and it caused quite a big argument, because in that family, everyone knew that the drinking cup that you had was always placed on the right hand side of the plate, and so that was me sort of not realizing that I was in the wrong. And that will happen to you, but it's much more if you're kind of aware of the fact that you're entering into a cultural domain, then you are going to feel as though, then you're going to be more aware of the fact that things are going to be different. It's much better than being blind to it. So you can imagine going into another culture and just ordering, like you're going to speaking this, not even going to say hello in the foreign language, asking people to, and so the sort of other points were that you don't have enough knowledge. That knowledge will come as you learn the language to be able to get a sense of whether or not you should use this inline style, or whether or not you should use, I would say, like the static method style as well. For things that feel like, for me in particular, I tend to use statements that are, I will try to use the static methods in places that seem like declarations. Whereas if I am working inside a closure, I need to use expressions. And so in that point of view, I will use toString. The third thing is that it's really Rust's fault. Because Rust is not an object-oriented language, it doesn't have inheritance. It needs to, but it makes heavy use of traits. So the situation is actually worse than these two choices. You've got a couple of others. One is toOwned. You could use into, although into is going to require that you provide it with an actual type hint, because it's unclear what you're trying to convert to, if that makes any sense. And there are at least a few others. We could, for example, we're kind of getting into nonsensical territory, but one thing we could do would be to iterate over every byte or every character and then collect them up in a string. So essentially mimic the process of applying a memcopy. So we could create an iterator, or actually which is chars, and then we would collect into a string. And then we introduce what I think is probably the most fun part of Rust syntax, is so-called turbofish. If you're new to Rust, you might not know the turbofish. The turbofish is this kind of interesting character, this syntax where we have two colons and then angle braces. It's been taken up by the Rust community at large. However, it has a subtle downside in that the person that created the term has actually died since inventing it, and so I always kind of think about that as well. That you kind of anyway. So we have all of these points in which Rust makes you choose. There are other choices as well. Is it debug? Is it display? Which might not make any sense unless you are actually doing the thing. But the debug versus display, or is it into, or is it from, or is it a string, or is it string slice? All of these choices are points which beginners get stuck on, and because they're worried, they want to do the so-called right thing. And I think it's okay to feel anxious, but it's also okay to give yourself permission to be wrong, because you're learning. You're literally learning. You don't tell a 6-year-old who's learning to read that, I don't know why you can't spell the word because, you know, or island. You know, these are words which are, you have to learn even as a native speaker, because English is has had such an awkward and essentially warped history that the pronunciation and spelling rules are no fit for how things are actually spelled. The same thing happens with Rust. Rust, for different reasons, but you wouldn't tell a child or someone else learning something that they were wrong just because they didn't know something that comes next. Give yourself, you know, accept that you're learning, accept that you need to give yourself permission to learn. I do also, so I'm several minutes in, like 12, but Rob's comments are also very valid, that they are largely interchangeable. And the point about toString and display types is also something that's worth mentioning. So if we go to the standard library, and this is something I do fairly regularly, I am a big proponent of looking through I'm a big proponent of looking through the standard library. And the thing that we're going to look for is that we have several traits. One of them is toString. There is, in fact, all of these methods here are backed by a different trait. So this is the toString, which is related to display, slightly indirectly. This is the from trait. The example on line 6 is backed by the toOwned trait, which is in standard borrow. So this is, and then this one is the into trait. So you can see here the fact that we have to use multiple traits adds confusion. Each of these traits are semantically independent. They don't form a nice hierarchy of types in the same way that an object-oriented language does. So that is that's sad. This thing here, cars collect or chars collect, depending on your pronunciation, is not backed by a trait. So the strings or string slices have a method on them, characters, that returns an iterator over the characters in a string slice and returns an iterator of char, which is a 4-byte Unicode scalar value, and at each iteration step, sorry. And iterators, I wonder if I can find it. So char, so it returns this struct, which has a reference back to the original. We can actually go and look at the source. So when you call the chars method, it returns this chars struct, which is a, let me find the actual implementation for it, which has as an internal implementation detail a reference back to a slice, which is the underlying buffer where the characters are actually stored. Now, all of this is irrelevant except for the fact that the collect method that we then call is related to iterator. So the iterator trait exposes a collect method, he says very optimistically, trying to remember off the top of his head. Yep, it's right there. Except for the fact that we need to provide a collection type. And so the collection type, such as a string, needs to implement the from iterator trait, from iterator trait that knows how to accept an iterator of the items that the chars iterator is producing. Gosh, it's all slightly convoluted. But by the time you're at line 8 and thinking, gosh, how do I create a string from a string slice? you should probably just pick one of the originals up here in line 4 and 5. However, the more broader story is that Rust's traits are heavily woven into the language that you see in a much deeper way than is probably visible when you first encounter the language. Okay, so what about programming in Rust by O'Reilly? I really like it. I've got it on my shelf. So this is related to the Rust in Action book that I mentioned before. So when it came out, Rust in Action was sort of a complement to the other resources that existed. You had the official book, which is the Rust documentation. So we're just talking about books and how to learn Rust, essentially. So the official book, the free book, was available online. Let's click Learn and find it there. Read the book. So this thing is, quote, the book. And it came out and explained basically the whole language from top to bottom. Programming Rust explained in much more detail how the language is actually implemented. It was sort of how to use Rust as a C++ programmer. Rust in Action, oh gosh, was an attempt to write a book that explains systems programming to people that had never used systems programming. And it did that also via examples like, oh, let's write a database. Let's write a CPU emulator. Let's write our own floating point format. And so that's what I did. And so that's why Rust in Action is different. It is not an attempt to be a reference book. It doesn't explain the entire language like Rust, the Rust programming language. It essentially gives you examples which are, I would say, they're all functional, but kind of like 80% complete, with the expectation that you could extend them in any way that you want. Okay. I'm just going through to the through the comments and seeing lots of Monty Python references. So clearly I need to watch the Holy Grail. I'll go back to my playground. And I am going to ask people, the only hard thing in Rust is async. That's a like highly controversial view. And I say that from like, there's like a trivial reason why that's true. So like it is more difficult. Like it's by design, it's additional. And so therefore it's slightly complicated. And I don't mean to single anyone out, except for the fact that it's easy to pull up comments like this. So there is an idea that let's think of something to process. So here I have my little struct, and it is a, let's say that I am a task. And I have an outcome. I'm using the word outcome because I don't want to use the word result. So, but we might as well say it's result, except then we get confused. Once the task is complete, we will have an integer. When it is initialized, we don't. This is only one way of several to model a task, but let's say that we have a function here, work, and work produces a task. Let's say we have init. and work takes some task. I'm going to use the variable name value so that we don't have to say task 400,000 times. And it's going to return a Boolean once it's finished. So sometimes I might call work, but not be done. At this point, I'm now talking about like multiple state machines and so forth. May also provide like some sort of input. And so I want some, let's say a vector of other numbers. And the input that, actually I'll ignore input. We always have the same thing. Let's just simplify. So the outcome starts as none. And then item outcome equals sum 42. So I apologize that this isn't a Monty Python reference. You know, this is a Hitchhiker's Guide. It's as good as I can do. I apologize. Don't hurt me. Right, so we've got our task. Task T. We initialize one. Yes, I could have used methods. Let's do that because that's a more elegant way to work. The problem with doing things on the fly is that you kind of get yourself into knots where you start to focus on things that are highly irrelevant and stylistic. So task : init. In Rust, we would usually use the convention new to initialize a new value, but here we're deciding that we don't want to, and t.work. Okay, so let's just, so the question here is, well, what is async and await, and why is it harder? This is going to be tricky to explain in 2 minutes, but I'll see if I can do it. Firstly, I should introduce some syntax. Let's say that work is an async function and returns, I also want to just try this. I wonder if I can make this more elegant with match, so that I've got a Boolean here, and I could just return it in the expression. So Rust is an expression-based language. It doesn't necessarily need the return keyword, and yet I'm just wasting time. Okay, so we've got this async function work, which returns a Boolean, but it also modifies some internal state in the struct. We update. And now that we've got a random number generator, why not just produce an I32? I just need to remember the API is super simple, which is why I typically turn to FastRand for examples like this. So we're going to say between 0 and 100, inclusive actually. So let's change that. Okay, so let's try and run this. Thinking about what is finished is. And I also need to implement a trait called debug, which will allow me to print out the value of t. Oh, except I'm masking the value of t inside of a print line with this : mini language. Aha, unused variable is finished. Okay, that's not particularly useful. So I've got a bug, and so we've got a couple of bugs actually. We cannot borrow as mutable as it is not declared as mutable. We can fix that actually by adding the mut or mute keyword. And now we're saying, this is an interesting thing. So this is another kind of subtle issue with, let's say, Rust. Actually, this is, let me just double check that I've got things right. Okay, so T is, run one more time. Okay, so when you see an error like this, you're thinking, oh gosh, Rust, what are you doing? All I want is to, like, literally all I want to do is print the thing out, and you're not letting me. Why not? And Rust is saying, Tim, mate, buddy, in the context of the scope, which is essentially from line 25 onwards, you have a live mutable borrow. That means that you have provided write access to somewhere else in your program. Rust's rules prevent any other readers or writers from existing while there is a writer available. The easiest way to get around this for now is to think about borrowing as lexical scope. And so you can introduce a new scope, which should get us around that particular problem. Aha, we do. Okay, so task outcome none. Wait. That's weird. We called the function, but it did, and in fact, let's print out as maybe it wasn't finished. Now, there will be people who hopefully will be screaming at the comments saying, Tim, fix that. And so, so I wonder if if this makes any sense to anybody. Our future import bool does not implement format display. Okay, well, that's weird because I thought it was just a bool. And the reason why I'm pointing this out, as well as making confusing error messages, is to kind of demonstrate what the async keyword is actually doing. The whole reason why we're looking at this is to talk about why async is hard. When you annotate a function with the async keyword, you're asking Rust to rewrite your code. You could think of the async keyword kind of as like a hidden macro that's very special purpose. I'm just checking to see if there are other people that are going to stamp on me for making this claim. And it looks like at this point, I haven't received any pen stamping on me. Except it's not, gosh, the only thing with writing it manually is that I need to get everything correct. Once upon a time, by the way, when async was being, it's output. Okay, it's not item. Once upon a time, You had to literally, in fact, you had to write worse than this impl thing. Impl in the return position didn't exist. And so you actually had to list the trait itself and say, I'm returning something which implements the future trait. And when that is ready, it will provide a bool. So the work method now returns straight away, but it doesn't actually do any of this computation. Instead, what is being returned is a so-called future. And in fact, we don't even know the concrete type. All we know is that it is a type that Rust can decide, or the compiler can decide, or that implements the future trait. All we know is that when you ask the future for the value, that it will return a Boolean. But is finished is not a Boolean. So this will have multiple, so like bool is not a future. Actually, that's a different problem. Okay, so the other thing that I've done wrong, or done wrong is a kind of a strange thing to say, is that now my return types are all wrong. So I promised Rust, I said, hey, look, I'm returning this future thing. Can you help me out? And it said, well, dude, you are actually just returning plain old values. That's no use. So I could throw on an await, .await keyword. What that does is sort of a similar thing, whereby it will take the expression and wrap it in something that can be awaited, that implements the future trait. Now it's only allowed inside async. So the so we could, if we wanted to, define, like, this is the value. We could return an actual future. So, and to do that, we would implement, like, we'd have to pull in futures 0.3 or futures light, and then actually throw the thing inside. It's complicated. We're not going to bother because we have the special syntax now. We are we're in modern Rust, or or relatively recent Rust, and so we can just return back things that look and feel like Booleans, even though the type system thinks that they're significantly different. And in fact, the implementation also thinks that they're different. So the async keyword is a shortcut for modifying the return type for a function. The .await is shorthand for taking a future and then asking for its value. So actually, me putting it in here wasn't particularly correct. But it kind of sort of is, because, and I know this is complicated, await itself is a future. It's futures all the way down. Again, to like mix, that's a Discord reference, I suppose. And the sort of touched on Monty Python, Hitchhiker's Guide, and Discworld. Any more that I should cover? So what is finished? It's not a Boolean. It's like, but I found a future. Note that we don't have future in capital letters here. In fact, we don't actually get told what the concrete type is. All Rust tells us is that it is something which will implement the future type. But we don't see the concrete type in source code. We don't have a definition like we did with our task of the future itself. We don't. I mean, what we could do if we really felt like it, which we really don't, will be a task. We could have the thing in here, which is something else, which is a task, and we could implement future for our thing. We could do that all manually if we really wanted to, but instead we've got all these helper keywords to do that for us. So you could think of async and await as being special purpose macros for writing code that creates both types and traits that actually, they just create types. The traits are already written. They create types which are able to work with your code in a relatively straightforward way, with the very significant proviso that the error messages become significantly more opaque. Because you're like, dude, compiler, here's my Boolean. It's right there on line 16. It's there on line 18. It's true or it's false. And you're telling me here down on line 27 that is finished is not a Boolean. Like, look at the return type. It says Boolean there. Why can't you find it? Why is that not a Boolean? And this is why people get confused, because they look at the source code and think that's the code that the computer is actually thinking about. But the compiler uses async, rewrites your function, changes the return type underneath you, and gives that to isFinished. So if you are confused by async, again, this is another instance in where the different priorities of the Rust language are in conflict, and the learning process is harder. So you as the learner need to figure out, so you as the learner just need to remember that this will all come. Like, to me, I don't see this as alien anymore, which strikes me as, which is kind of bizarre when I explain it out loud, that Rust is doing all this work underneath you and your source code isn't actually the code that is compiled. But I know why they did it. And they did it because they wanted to provide, I say they, the Rust language team, really wanted to provide an experience that's as easy as possible while also being extremely high performance, that you could not write faster code yourself. Because here's the other thing, that even if you get all of the syntax right, so we'll just avoid isFinished, we'll just avoid defining the type. Even if you were to get all this right, oh gosh, it's saying, oh, it doesn't implement display. Okay, cool. Yeah, whatever. Like, we'll just use debug then. Doesn't implement debug as well because, oh gosh, okay, so we can't even print it out. That's cool. We'll just, even if we got all this right, our task is still going to be outcome none, because we haven't actually sent any work forward. So one of the things that we could do would be to poll. The poll method comes from the future trait. So we go back to the standard library documentation. I know this because I've been around Rust for a while. And I know that futures have a poll method, and it returns something that's even more bizarre. It returns this poll thing that has self wrapped in pin. Huh? We haven't seen that before. And we need to supply some sort of context argument, which we don't have access to. And then we get a poll thing, which probably is going to provide an output. So this is also going to, polling or calling poll is the way that you get a future to do some work. You essentially, another word you might be able to use is like step, or you could ask it to move forward in some way. And you are essentially nudging the thing forward. We don't have any context, so we kind of need to provide some. And I'm going to see if I can, this is all going to sound really, so we need what's known as an executor. Gosh, I've just jumped around tabs. And an executor, you could think of it as conceptually like this. So let mute executor is, let's just say that we had an executor, we initialize it, and then the executor, we don't have keyword arguments in Rust, but let's say that we had CX context, and then so we would have the output, and then the executor would somehow know how to get value from output. It's not even very accurate in terms of how it works, but we could think of the executor as doing something in conjunction with a future. It's essentially driving the computation. Another way to look at it, it is executing the function. Gosh, it's right there in the name executor. As long as you don't think of executor and the like killing, like the English language is very odd. Now, I need to drive us back to reality because we don't have the ability to pass keyword arguments. We don't need to, we're not really sure what the executor has. In fact, we don't even call poll ourselves. The executor does that. So wouldn't it be great if there was like a baby executor? And so this is where Tokyo comes in, by the way. So here's the kind of the great the great reveal that we have a runtime. Gosh, that's actually subtly different to what I'm talking about. The runtime includes much more. What we really just care about is an executor that can drive computation forward through an executor. So what we want to do is this is already too much. So we've got these nice helper macros, but it's pretty close. If we go to the implementation, let's look in the internals of what this Tokyo main helper macro actually is. For two reasons. One of them is that it's exactly what we need to do outside of the macro, so what we need to do right now if we wanted to do computation. Also, there are some other projects, like most web frameworks have also taken on a convention of providing a wrapper around main to enable main to be async. And I'll get to that latter point later. So what we need to find now is main. And specifically, the only problem is that we need to find the macros. So I think this here is the macro. Now this is quite complicated because it's the actual macro. So it's talking about how to parse the source code. So I kind of don't care about any of that. I just care about this build config thing. So gosh, what's that? And here is I need to go find build config. What it's trying to do is create the configuration for a Tokyo executor and then implement it. There is we'll stick with this. There is actually a simpler way forward, which avoids Tokyo, but we're in Tokyo land now. So let's figure this out. I feel like we're on the quest. We should finish the quest before proceeding. Build config. So this is a bunch of things that you can specify to the executor. So for example, if you wanted to, let's just do it in our code anyway. So if I was to use this in, I would say Tokyo main, and now this becomes async. I don't need an executor because the executor new is actually what Tokyo main is setting up. That's the config for the executor. So one of the parameters that I can provide would be num threads, I think, or core threads is renamed to worker threads. Okay, so let's say that we wanted a multi-core executor. In fact, I might just ask for a single-threaded executor just for fun. And you know what I'll do? I wonder if this will work. I have an interesting thing that I can do, which is to ask the compiler to spit out the macros, like the code that will be sent to the compiler. Current thread. Current thread looks fine. Okay, we'll do that. No, wrong. Expand macros. Not run. Executor is okay. Actually, this is good because we're at a compilation error. So it's, but this is actually what I wanted to do. So ignore the stuff around how to implement debug. I kind of don't care about that. What I care about is what main looks like, because that's curious. It looks different. I'll just get rid of that. So this is the nice code that you see normally, and let's put the ugly code in, and I'll delete some lines that aren't necessary anymore. So this is the same thing as doing this. Just to clean it up ever so slightly, I'm going to call one more tool, which is Rust format, which should actually just clean this up. Here we are, finally. Here is my Tokyo runtime builder, new current thread. What this does is return a, we don't need the macro. I don't know if I'm going to get rid of this print format args thing as well. Yes, and we're just going to replace it with the nice code. I say nicer code. You'll note though that the async block the async, it's not a block, it's an expression, needs a trailing semicolon, whereas I had it here on main, but so here's executor. And what I wanted was like, what we tried to do was like, is finished. This is the code that we're trying to replace, poll. And we somehow needed to, what did we need to do? We needed to give it a context. And we thought, oh yeah, we'll pass it in some sort of executor.context or something. We don't know what it's supposed to be. We're crazy. We're blind here at the moment. But we just want T. In this case, it's up in line 41, but this is what we want. We want it to compute some actual value. We want it to not be none anymore. We're sick of none. We want some. In fact, we want some between 0 and 100. That's why we're here. We're here to figure out what's going on. Ignore all of this. Most of this is junk. It's telling us that it's relaxing some clippy lints because it's auto-generated code, so the user isn't going to be able to do much about it anyway. But none of that is really... Oh, actually, I do need to bring in... So we put all configuration, we enable it all. Then we build, which creates the executor. But we also need to... It returns a result. And it includes an executor inside. It probably includes a result inside it. I'm just teaching you some other crazy Rust, just in case you felt like confusing your colleagues with some unconventional code. It's commonplace to call expect, like you have been. However, we can also just use patterns with let. So you've probably seen if let for some, but here you go. We can actually call it on results as well. And otherwise, we can panic. And we'll just add a tier because that's the kind of feeling, I don't know, is there a better tier? Building the Tokyo exec, let's say runtime. They use the word runtime because Tokyo is actually more comprehensive than just the executor. We don't care at the moment. What we're really, really interested in doing at the moment is expanding the line 49. We don't have that. We don't actually, body is all we have access to. We don't have access to T after body is wrapped up. So kind of, you could think of it like we don't know anything inside there. But we do have a future. So we know that the async keyword takes an expression and converts it into something which implements future that can be awaited upon. So what happens is you call executor and then say block on. Perhaps it would be more fun and more if you just said, if they had a helper method, which was start. Like start here. But they don't. In fact, instead of having a specialist method that, a specialist method, a specialist method just for initializing the very first future, that, by the way, is not async. So remember, now that we are not in macro land, we're not using Tokyo main. We are just in a plain main function that is in synchronous mode. We need to stay in synchronous mode, so we block. This is a blocking call to body. Oh, sorry, it is a blocking call that will not return until all of the computation inside of the body expression is finished. Maybe that makes sense. Maybe it doesn't. And sadly, when I click run, it is still going to say none. T will not be done, will not be finished. The question that you have got about 7 seconds to answer, unless you push pause because you're watching the recording, is why not? We've called work. I suppose in this case, it's random. So it's 50% of the time it's still going to be some, but let's actually just change that so that I can guarantee that okay, we'll do this to kind of avoid any confusion. Outcome is still none. So you've had more than 7 seconds. So I'm going to sort of let you in on the trick. Work returns a future, not not a value. So we need a value. So we need to await inside of our async block. Now we can while I wonder if I can do this actually. In fact, it's not while. It's gosh, let's get this wrong. Let's get this run is finished, and then we'll clean up the code. If is finished, we time for coffee. We're done, so it's coffee break time. So we now have working code. And now you know why async is complicated. So to go back to that original point of, gosh, why is Rust async hard? It's because it's literally a new, the compiler is writing a whole bunch of code that is not in your source code and compiling that. And it also introduces a completely new paradigm of thinking about the way that computation works. And that is, instead of it being synchronous, or at least being sort of linear with branching, that is, we follow the steps from top to bottom, you can arbitrarily be suspended. You can have other parts of your program executed, and it's actually not quite accurate. I just made a mistake. If anyone is into symmetric multiprocessing or cooperative multi-threading will understand what I mean. Your current task is not interruptible unless you sort of have special guards. But the general principle of the fact that, and I'm trying to find the actual comment, was that we don't have, gosh, I'm trying to think of, find the comment from several minutes ago. Like, the only thing that was hard in Rust is async code. And I don't think that's accurate, because there's actually lots of subtlety in the language. There are lots of places to get stuck. So I don't think that if you're stuck somewhere else, you should somehow feel like you're less of a Rust programmer. But async is particularly difficult because it's different. You don't actually see the code that is being compiled. You don't see the execution flow in the same way that you would read a book. It's much more like a choose your own adventure, if anyone still rolls the dice and like does choose your own adventure books. And like interactive fiction, maybe, which is probably even more niche. You jump around a lot. It's kind of part of the game, and that's tricky. The other thing that makes async really hard is that most people that come to Rust to do web programming. They want to build APIs. Most web frameworks in Rust are written in async Rust. That means that async is being learned by people who are learning Rust. So they kind of have to learn like 4 things at the same time. When we run out of working memory, when we exhaust our working memory, we're less able to learn new things anyway. And so those are one of the reasons why those are one of the reasons, like, there's a whole bunch of reasons actually Rust is really hard, and those are one of them. By the way, I should ask if anyone is actually still watching. I've got no idea if you are. I don't actually see my numbers up here. I like intentionally I want to do one final plug, and that is, if you're coming, if you're close by to New Zealand, or if you want to see more of Rust, we want to see me. I'm organizing a conference in August, and you can be there. You have 6 months to plan. Yes, it's expensive. Yes, it's far away. But yes, it is achievable if you set your mind to it. And I totally want you to come. If you would like some sort of code or discount, give me a ping in my channel, like in my Discord channel. So I'll have it in the show notes. But the thing to search for is Clicks Lounge, which is a strange thing, I suppose, to think about with Tim Clicks. So Clicks Lounge is my Discord server, and I'll try and drop a discount code for the conference itself. I'm putting it on, and you get to generate. Like, we are going to have a tour of a fusion reactor, a fusion reactor as well, which is going to be pretty sweet. And so see you there. Okay. Otherwise, see you online. Feel free, if you are watching this wherever you are, to just leave comments, and eventually I should be able to get back to them. But if you want to be faster, just ping me on social media. So I'm pretty much Tim Clicks all over the place, and I'm looking forward to receiving your comments and feedback and all the rest of it. So with that, I'll take a big breath and wish you all well. My name is Tim Clicks. I'm on the planet to build a better planet. I just need to remember how to get rid of this. This is my first stream in ages. Here we go. Look at that. Bye-bye.